You know, in the world of aviation, some of the greatest dangers are the ones you just can't see. We're talking about an invisible force of nature, a sudden, violent column of air that can literally punch a plane straight out of the sky. So today, let's break down the microburst.
Just think about that for a second. Thousands of feet per minute. It's a staggering, almost unbelievable rate of descent. And it's this raw, concentrated power that makes microbursts one of the most feared weather phenomena for any pilot.
And look, this isn't just some theoretical threat. The struggle to understand and survive these events is a story of tragedy and incredible innovation. A story that completely changed the way we fly and the technology that keeps us all safe in the air.
And that's really the core of what we're digging into here. We're going to look at what a microburst actually is, what it feels like to fly through one, and then explore the incredible procedures and technology that were developed to defeat this invisible killer.
All right, so let's dive right in. To really get a handle on this, we first need to understand exactly what we're up against. What is the anatomy of a microburst?
The absolute best way to picture this is to imagine a giant fire hose pointed straight down at the ground from inside a thunderstorm. That powerful column of air is the downdraft. When it smashes into the surface, it has nowhere to go but out, spreading in all directions. And this creates a vortex of violent, shifting winds right where planes are most vulnerable, during takeoff and landing.
Now, they basically come in two main flavors. You've got your wet microbursts, which are pretty much what you'd picture, a very visible, intense shaft of rain just pouring out of a cloud. But then you have dry microbursts, and these are way more deceptive. They're often marked by something pilots call virga. That's rain that actually evaporates before it even hits the ground. The only sign you might see is a curling ring of dust being kicked up on the surface, a really subtle but deadly giveaway.
And what's kind of shocking is just how small they are. A typical microburst is less than 4 kilometers, or about 2.5 miles, in diameter. It's an incredibly localized event, but it's just unbelievably intense.
And here's the kicker. They don't last long at all. The entire lifespan is usually just 5 to 15 minutes. This short duration is precisely why they're so dangerous. They can form, strike, and disappear before they could be reliably tracked or predicted with older technology.
So, to truly understand the danger, we need to break down the terrifying experience of actually flying through one. For a pilot, it's a very distinct 3-stage trap.
Okay, so first, the plane hits the leading edge of the outflow and gets hit with a sudden, strong headwind. This actually makes the plane perform better, causing it to lift or balloon upwards. A pilot might even be tempted to pull the power back. But then it enters the core, and a massive downdraft just slams the aircraft towards the ground. Finally, as it pops out the other side, that helpful headwind instantly becomes a powerful tailwind. This catastrophically robs the wings of airspeed and lift, causing a massive sink rate right when the plane is closest to the ground.
And to put that into perspective, in the landmark accident involving Delta Flight 191, the aircraft lost 58 knots of airspeed in just a matter of seconds when it hit that tailwind. That is an almost unimaginable loss of performance.
So that raises the million-dollar question, right? If you find yourself in one, if you can't avoid it, how on earth do you survive it? Well, the answer came from studying the tragedies of the past.
This became the new philosophy. Investigators of the Delta 191 crash realized the plane hit the ground while its engines were still capable of producing more thrust. The lesson was brutal, but it was crystal clear. In a microburst, you use every single ounce of energy your aircraft has to stay in the air. And that leads to the single most important survival concept. You stop trying to maintain your speed, you pitch the nose of the plane up to fight for every inch of altitude. Your goal isn't to fly fast, your goal is to fly away from the ground. Your angle of attack is way more important than your airspeed, as long as you don't stall the wings.
So all of this was developed into a formal life-saving procedure. The moment a severe downdraft is suspected, pilots are trained. Disconnect the autopilot, firewall the throttles for full power, and pitch the nose up to about 15 degrees. Then get the landing gear up to reduce drag and just fight the bear. You hold that nose up attitude and you power right through it. Don't worry about speed, worry about survival.
But of course, surviving a microburst is the absolute last resort. The real goal is to never, ever encounter one in the first place. And that has led to a whole modern system of defense.
And the catalyst for all of this, the true watershed moment, was the 1985 crash of Delta Flight 191. That accident took what was a poorly understood phenomenon and thrust it into the spotlight, forcing the entire aviation industry to develop new tech and new training to combat it.
And from that one single tragic event, multiple layers of defense were born. So today, airports are equipped with advanced Doppler radar and wind shear alert systems specifically designed to see these things. Pilots spend countless hours in advanced simulators practicing that escape maneuver until it's pure muscle memory. They're trained to spot the visual cues, like those rain shafts. But the most important rule of all, the golden rule, remains. Avoidance is the best defense. If you even think there's a microburst, you just don't go there.
And it really leaves you with this final kind of profound thought. The average microburst lasts about 8 minutes, but the lessons learned from those terrifying 8 minutes have led to decades of innovation in technology, training, and procedures. A legacy of safety born from tragedy that protects every single one of us when we fly today.